Welcome to the lecture for CHO 351 for MSc-II organic class. In this lecture, we are going to discuss about the mass fragmentation of aliphatic alcohols. Aliphatic alcohols are with alkyl. So, when you consider the alcohols, that may be primary, may be secondary, may be tertiary. Okay. So, in primary alcohol, molecular ion peak is weak. Also, in secondary, same thing, that is the molecular ion peak is weak, but in tertiary alcohol, very weak molecular ion peak. Also, second thing is that alpha cleavage is occur in fragmentation of alcohols. This alpha, so this bond is break here, this alpha bond. So this alpha cleavage many times you can observe in mass fragmentation of alcohols. Alpha cleavage we call. So after alpha cleavage you can observe the peak because of primary alcohol. In primary alcohol we can observe this peak. That is the mass to charge ratio 31. At this value we can observe this peak in primary alcohols. In secondary alcohol we can observe the peak, that is CHROH. So this peak we can observe. So R group may be any group here. So here peak we can observe mass to charge ratio, that is the 45, 59 and 73 etc. Okay, for secondary alcohols. And remember that for tertiary alcohol both groups are here like this, R dash OH with positive charge here. So mass to charge ratio, this peak we can observe at the value, that is the 59, 73 and 87. At this value you can observe the molecular ion. Sorry, you can observe this kind of peaks in second tertiary alcohols. So during alpha cleavage, generally larger R group, larger R remove as a radical. That group remove as a radical. Okay. Also remember that during fragmentation of alcohols, when gamma hydrogen is present, in alcohol, gamma hydrogen is present, that time alcohol lose the water molecule, H2 is loose. Okay, loss of water means M minus H2 peak we can observe. Also, when delta hydrogen is present, that time we can observe the M minus H2 plus alkyl. So this overall we can observe the peak. So delta hydrogen is present. When say M minus 18 peak is observed, here we can observe the peak because of water molecule. When you do the ethene molecule, M minus 86, M minus 74 and M minus 102. So that kind of peak we can observe in mass fragmentation of aliphatic alcohols. So let us discuss with example here. So consider the example of 1 propanol. Bombarded with electron. After bombarding with electron, you know very well, the non-bonding electron is usually that non-bonding electron are removed. So But we can show the molecular ion like this here: CH3, CH2, oxygen, one electron is removed. So here positive charge, NH. This is the molecular ion. This molecular ion we can also write like this: CH3, CH2, CH2, OH. So overall radical positive charge. This molecular ion peak we can observe at mass charge ratio 3 carbons. So 3 carbons, 7 hydrogens and 1 oxygen. So 3 carbons, 8 hydrogens and 1 oxygen. So 36 plus 8 plus 16, this come out to be 44 plus 16, this come out to be, that is the 44 plus 16, this come out to be 60. So at this value we can observe the molecular ion property. After this molecular ion peak undergo alpha cleavage. Okay, alpha cleavage means like this. So larger alpha group is removed as a radical. So during that, this carbon CH2OH acquire the positive charge. So this peak come out now to charge ratio 31. So this is the characteristics of this primary alcohol, and it gives as a radical. Means M minus 29. We can observe. Also in this primary alcohol there is a gamma hydrogen. So because that we can observe like this: CH3, CH2, CH2. This is the molecular ion peak. From this molecular ion peak, we can show the alpha, beta, and this is the gamma hydrogen. So when gamma hydrogen is present, that time, so this gamma hydrogen is attracted like this by this alcohol, like this. So here this becomes CH2 radical, CH2, CH2, OH2, like this. So this becomes like this. So after that, this is removed as a water molecule. So M minus 18. So M minus 18 means overall CH2, CH2, CH2 plus, and this is a positive charge, this is the radical. This peak we can observe after charge ratio 16 minus 18, that is the 42, because of loss of water molecule when gamma hydrogen is present. So here delta hydrogen is not present, so it does not undergo further loss of alkene plus water molecule. So in this way we can show the mass fragmentation, that is the loss of water molecule, loss of alkyl group as a larger group as a radical. So in this way we can show mass fragmentation. Next example, 2-propanol. Suppose direct stream is the molecular ion peak combined. This molecular ion peak we can already mark the charge ratio 60 value. Okay. So after this is secondary alcohol. So we can remove this group as a radical, that is alpha cleavage. After alpha cleavage we can remove any group here. Both groups are same here. So we can get the CH3CH OH and this positive charge and this group as a radical like this. So M minus 50. So mass to charge ratio we can observe the peak at the value 45. So here in this alcohol there is no gamma hydrogen, so there is a no question of loss of water molecule. Okay, so this is kind of fragmentation we can show for propellant. Next is the two-butanol. Suppose we consider the example of two-butanol. Two-butanol. Okay, so we can write the structure of two-butanol like this here. Okay, this is a two-butanol. So suppose I write here this is the molecular ion after bombarding. We can write the molecular ion like this, mass to charge ratio. So this compound contains 4 carbon, okay, and number of hydrogen is 6. 6 plus 4, 10, and 1 oxygen. Okay, so 48 plus 10 plus 16, so that come out to be 58 plus 16, that come out to be 68 plus 6, that is the nothing but 74. So at this value we can observe the molecular ion. Okay. Next is the, you know that alpha cleavage. During the alpha cleavage we can remove the generally larger alkyl group as a radical. So here M minus 29, we can observe here M minus 29. So after the loss of M minus 29, we can observe the peak like this. And this is the group as a radical. So M minus 29, 74 minus 29, so this value come out to be 45. At this mass to charge ratio we can observe the peak because of alpha fragmentation. Next is the, in this compound we can observe the gamma hydrogen. When gamma hydrogen is present, we can write CH3, CH, CH2, CH3. So we can write the molecular ion in this way for showing the loss of water molecule when gamma hydrogen is present. So this one electron is in one here. Okay, this one electron remains as it is here. So because of that, CH3, CH, this becomes OH, OH2. Also here CH2 and CH2 radical. So with one electron is form the bond with this oxygen, and because of that, this one electron is involved, and because of that, this lose the water molecule. And when this lose the water molecule, loss of 18. Loss of 18 means molecular ion peak 74. CH3, CH, positive, CH2, CH2, radical. So at this mass to charge ratio means after loss of water molecule, we can observe the peak at mass to charge ratio. That is the, at which value? It is the 74 minus 18. So at this value, 56, we can observe the peak. So in this way we can show the mass fragmentation for two-butanol. Next is the next molecule we are going to consider here, that is the 2-hexanol. Suppose two-hexanol. Okay, in 2-hexanol, this is the suppose molecular ion. So this molecular ion we can observe at mass to charge ratio at the value that is the 102. At this value we can observe the molecular IMP. So here, because of alpha cleavage, you can observe the two kind of alpha cleavage. Here this is the alpha carbon, this is the beta dash. So larger molecule is removed as a radical. So 1, 2, 3, 4. So M minus 57. M minus 57. And because of that, we can observe the CH3, OH, CH3. So this peak mass to charge ratio, that is the 30, 45. And why? CH3, CH2, CH2, CH2 as a radical. So at this value we can observe the peak. Also because of methyl group as a radical, suppose to remove the methyl group as a radical, M minus 50. So CH3, CH2, 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 CHOH, like this. So plus methyl group as a radical. Okay, 102 minus, that is the 102 minus 50. So that value will come out to be 87. Mass to charge ratio 87. At this value we can observe the peak because of alpha fragmentation. Next is we have to show here loss of water molecule because here gamma hydrogen is present. When gamma hydrogen is present, we have to show the loss of water molecule. For this, I show the molecule IMP this way: CH3, CH2, 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 CHOH, CH3. Okay, alpha, beta, and gamma. Okay, this gamma hydrogen is abstracted by this. One electron is combined here, this electron is remained here. So overall loss of water molecule M minus 18. CH3, CH2. Okay. CH as a radical, CH2, CH, like this. So from this we can show the loss of 18, like CH3, CH2, CH radical, CH2, CH positive charge, CH3. So this radical and positive charge, so this peak, here we can show the radical, here we can show the radical. So this peak we can observe at mass to charge ratio, it is 102 minus 18. 102 minus 18. So here so this peak we can observe at the value 84. So in this way we can show the loss of water molecule when gamma hydrogen is present. As here alpha, beta, gamma, delta hydrogen is also present, we can show the loss of alkene plus water molecule. See here how. Here M minus H2O plus alkene. This loss also we can show when delta hydrogen is present. Okay. So here for this the molecular identification like this here for this remote. So number of carbon 6 at 2 position will be present 2 hexagon. So molecular identity we can show like this here. Molecular identity at mass to charge ratio 106 value. Okay. So here alpha, beta, gamma and delta. Okay. So you have to show the abstraction of this gamma hydrogen, so delta hydrogen, alpha, beta, gamma and delta. Okay. So when you show abstraction that time, see it. I show the transfer of like this. So same way we can show the bond between alpha and beta carbon. Same time bond between beta and gamma carbon is break here. This is shifted here like this. So here this is removed as a water, which this OH and this H remove as a water molecule. Okay. Same time this group is removed as a bond between alpha and beta. We have to remove as a alkene molecule. Means here CH3 and double bond CH2. So alpha and beta. This group remove as a alkene part. And same time this part gamma and delta between this CH3 CH CH2, or this we can show like this charge to like this. So here this alpha and beta, this is from the alkene, this from the water, and this overall this over that we can show the radical positive charge. That is gamma, delta and gamma, delta and gamma hydrogen. Okay. So here radical positive charge. So this we can observe in mass spectrum at mass to charge ratio. So 106 minus as a water 18 plus this alkene is removed here. For example, we can write the 28 plus here 14. So 18 plus 40, that come out to be, I think, 42. So 42. So overall 42 plus 18. 42 plus 18. So you have to show loss of overall 16. How much? 16. So 106 minus 16. So that value is come out to 46. So 106 minus 16. So at this value we can observe the peak in 2 hexagon. So in this way we can show the mass fragmentation in alcohols. So alcohols will undergo mass fragmentation that time, loss of water molecule, alpha cleavage, also delta hydrogen is present that time. We can show that this kind of removal of alkene plus water molecule. So this is all about the mass fragmentation of aliphatic alcohols.